Welcome to NSOMASA NMIMS podcast, where we bring you exciting conversations with the thought leaders from various fields. I am K.S. Madhavrao, Professor of Statistics from the Department of Statistics, NSOMASA. Let's welcome our guest, Professor Nagaraj Neerchal, who is a distinguished Professor of Statistics at the University of Maryland, Baltimore County, USA, who has been interviewed by Nandini Bhosle and Satij Raste.
Hello, and welcome to the very first of its kind podcast, where we, the students of ICS conference organized by NMIS and NSOMASA, have cumulatively gathered to seek and store the overflowing wisdom of our eminent and world-renowned guest speakers. My name is Satij Raste.
And I am Nandini Bhosle.
And we are the host of this podcast. So, to the all listeners listening, we like to introduce our speaker today, Professor Nagaraj Neerchal. So, a little bit about Professor Nagaraj Neerchal. Professor Nagaraj Neerchal is a professor of statistics at University of Maryland, Baltimore County, with a research focus on modeling correlated data over time and in clusters. He enjoys working on real projects side by side with scientists and engineers to provide the best statistical advice for their project.
Apart from his academic pursuits, Professor Neerchal is also passionate about arts and culture. He is a Yaksha Gana enthusiast who has performed and promoted his ancient folk art from coastal Karnataka. He is also involved in Toastmasters International, a global organization that provides opportunities for individuals to improve their public speaking skills. Professor Neerchal believes in power of communication and encourages everyone, whether confident or fearful, to experience Toastmasters. Lastly, Professor Neerchal is an active member of Chinmaya Mission, which is a global non-profit organization dedicated to spreading knowledge of Vedanta and practical application of its principles in daily life. He also officiated Chinmaya Vishwavidyapita deemed University, Ernakulam, Kerala as Vice Chancellor during 2019-21 on a sabbatical from his host university where he is currently working. Professor Neerchal's dedication to service and his diverse interests reflect his deep appreciation for learning and understanding different cultures. Now, we will start the question segment.
So, good morning, Professor Neerchal.
Good morning.
So, our first question is that your educational background includes both Indian Institute ISI and Iowa State University. So both of them have different kind of curriculums. One is theoretical based and one is more application based. So how these two universities have affected your statistical point of view and your knowledge of statistics?
First of all, thank you very much for that very kind introduction. I really appreciate that. And you guys seem to have done a lot of background. And I think when someone being introduced, it always feels like they are talking about someone else. It's not about you, really. So it's very kind. Thank you very much. And it's a great question. I was very fortunate to actually get into ISI immediately after +2, right? ISI, I did my bachelor's and master's in ISI. And I think possibly without any argument, one of the best places in the world to get statistical training. And I was very, very fortunate. And instead, in ISI, we got a very good theoretical foundation, I think, as you already mentioned. And but what really attracted me to statistics has always been the applications. I still remember my PU, the second year probability course, and the probability teacher was talking about modeling data using Poisson distribution, and how once the model is derived, you can answer practical questions with it and so on. And it was what really felt that I want to do this, learn this subject, and I want to learn more about it. So the applications was my draw. So when I finished my ISI master's, I was really fortunate to get into Iowa State University, which is actually one of the best places to get training in applied statistics. So I go from a very strong theoretical background go to a place where applications are very well emphasized. So this has actually formulated my career. Even today, I get very attracted to projects where statistical methodology is inspired by real life problems. And I want to be able to start my talk with the practical example and to motivate the theory and derive something theoretical, and then finish the talk with an application of the methods that I have derived. So this is, to me, is a very complete statistical project. So I feel that these two institutions together gave me a very good background to be what I really wanted to be all the time.
So, as you mentioned, that both ISI and Iowa University give you good opportunities. So, do you think there is some X factor in these universities, some common ground that makes students stand up apart from the crowd?
It's actually a very interesting thing that you're bringing up. It turns out that both ISI and Iowa State University are influenced by Fisher. The well-known Sir Ronald A. Fisher. He has been an influence on both the institutions. When ISI was founded by P.C. Mahalanobis, and he went to England to do a PhD in physics. There he met Fisher, and he became he became very interested in statistics, and he felt that the need of the hour in India at that time, because when he returned, we were about to become independent and so on. He thought that statistics was more needed in India. So he was inspired by Fisher to pursue statistics, and he came back to India. He founded ISI and so on. And he became a primary advisor to the Prime Minister during the 5-year planning and so on. So P.C. Mahalanobis is a very influential person in the Indian history, in the modern, you can say he's one of the makers of modern India. In Iowa State University also, this is one of the oldest statistics programs in USA. And it was founded by people who are influenced by Fisher. And they established what is called a statistical lab. Iowa State Stat Lab, they call it Statistical Lab, just like the Rothamsted Statistical Lab that Fisher used to run, in the same concept. So they were helping people actually run experiments in Iowa State and collect data and analyze, just like Fisher used to do in Rothamsted. So I think there is that I see that commonality between the two, and I think there is even though one is theoretical school at that time especially, and the other one is more applied, they were driven by the same goal of being an application oriented.
That's very rare and interesting insight that you shared with us. Now moving on with the second question. You have worked on real projects with scientists and engineers in various fields. With your experience, what are the 3 most important qualities that a statistician or data scientist should have?
Now, I'll say very simply 3 things.
Okay.
Listening,
Okay.
seeing, and speaking.
Okay.
Listening, seeing, and speaking. So if you have trouble remembering this, your famous Gandhiji's monkeys, 3 monkeys.
Yeah.
So that is a good way to remember this. Okay. So listening, seeing, and speaking. Because if you want to be a good applied statistician, and if you want to be helpful, when the scientist or when the subject matter expert is presenting you the problem, you have to listen very carefully. Because more often than not, they're talking about a subject that you have not studied at all. Because I have helped engineers, I have helped biologists as a statistician, I have participated in environmental projects and so on. Every time they're going to talk to me about something that I have not seen before, I have not heard before. So I have to listen very carefully and understand it at least to the level that I need to understand. So listening is very, very important. And seeing, going and actually observing where the data is collected, for example. That's very important. I was working on a project dealing with detecting lameness of cows. dairy cows, they get lameness. They basically get their feet infected. So when they have infection, they don't eat well. And if the cows don't eat well, they don't give milk. Like this is, they're basically, they're like a machine. They eat food and produce milk. I mean, like that. So if they don't eat, they cannot produce milk. So it's very important for them to be able to detect the lameness. But they cannot really go and examine the cows because it's not very easy. They are not very, they will not sit down and say, okay, check my feet, right? So the engineers wanted to develop a platform on which the cows will walk, and they will collect the signals and then collect data, and basically like a machine learning based model of of predicting lameness based on this the sensor data. But in order to create a training data, a veterinarian had to examine several hundred cows and make each cow walk. So you have to create the training data, right, with the actual knowledge of lameness and right. So, but I went to see how the data is collected, how the veterinarian was collecting the data. And I saw that, every cow he was examining for 15, 20 minutes, sometimes 30 minutes, and examining each leg and see if there are lesions there and so on. And first of all, I realized that being a veterinarian is very hard work. It's a back-breaking work. You have to bend and, it's not at all easy. At the same time, I had an appreciation for where this data is coming from. So I would not flippantly say, hey, this is an outlier, I want to throw it away, because I feel that, he worked half an hour to collect this data. I don't want to throw this away. Like that, I became very invested in the project. So seeing, and speaking, of course, communication skill is the most important thing. It's not enough to be able to solve a problem. You have to, relay the solution to your client in an understandable way. Many times clients are not very knowledgeable about statistical methodology, terminology. You cannot just throw away type 1, type 2 error, and these very technical terms at them and expect them to understand. So you should always relay your results in an understandable way. So I'll say listening, seeing, speaking, right? So that is three most important qualities a statistician should have.
Truly, understanding and explaining our methods is very important thing. To add on to the question, if you could share an example of a particularly interesting or challenging project that you have faced it in.
So I mentioned the cow project. I mean, that is actually has been going on for a number of years, and see, the idea is that so the cows walk on a platform, and underneath the platform there are those what you call load cells that actually measure how much pressure the cow is putting on each leg. And if one leg is hurting, it is going to limp, right? So it is going to favor that leg. So it will be very soft on that leg, put all its weight on the other 3 legs. So that is the idea. So when the cow is actually walking, and if there is some asymmetry in the way the cow is putting weight, then you will say, okay, that must be lame, right? Because if it is not lame, it will be even, right? It will put all its weight on the 4 legs more or less equally. In fact, what makes this project even more complicated is that you have to do it while the cow is walking, because cow is very unlikely to stand still and let you take the measurement. So what they're doing is that as the cows are coming out of the milking parlor and they're going back to their pen, they put the platform on the way. So the cow is walking. Cow doesn't even know that it is walking on the platform. So it will be just walking normally. And as it is not going, at some point, each leg will hit one of the those plates under which the load cells are, at least once like that. So you have to let it walk for a few seconds, and so collect the data over a period of time. And there's a lot of data preparation you need to do, where the cow actually put the first time it touched the plate and so on. So a lot of data preparation is there. And so it's actually a very good example of functional data. I think yesterday, one of the speaker was talking about the functional data. So it's a profile, you get this profile. And so in fact, we came up with a methodology. There are a lot of, interesting part. I can give a 1 hour talk on this one easily. And we got a patent out of it. I'm part of a patent of, this lameness detection patent. So I think I would say it's one of the most, and it's also long. I think the project continued, I think almost 10, maybe 12 years. We produced maybe 3 or 4 master's students and a couple of PhDs. So it's a very fertile project on a long period. So I would say one of the most interesting projects I have been part of. I also worked with a lot of environmental data. I'll talk about it later on, I think, when it comes up.
So
on the same lines as you have suggested that this is environmental statistics related project. So how did you came across environmental statistics? Because a lot of data scientists have this kind of buzzwords like AI, NLP, and data science. So they don't understand environmental statistics. So can you explain your motivation and how did you came across it?
Say, in US, there is something called US EPA. United States Environmental Protection Agency. Yesterday, one of the speakers was talking about the Federal Food and Drug Administration, right? Similarly, EPA is the body that kind of maintains regulations related to environment. So, U.S. government has come up with something called Clean Air Act, that actually puts some restriction on what the allowable pollution should be, etc., etc. And Clean Water Act, so that, what is the expectation for drinking water, what kind of pollutions, level of pollutions is allowed before you can determine that it is not drinkable, and things like that, so several parameters like nitrogen cannot exceed something and so on. All these kind of issues are dealt with this US EPA. So this naturally leads to statistics, because one of the Clean Air Act, for example, says explicitly, the law itself says that you must determine this whatever status of the thing based on a representative sample. It actually says representative sample. It does not say random sample. It says representative sample. So it immediately is like an invitation for statistics being used, right? So naturally, as soon as some of these things started popping up, statisticians were in demand. So immediately they needed to get involved. So in my case, what happened is that, I live in Baltimore. I don't know whether you are familiar with the Baltimore US map or not. Baltimore is about maybe 35, 40 miles north of Washington, D.C. And that whole area is part of a estuarine system called Chesapeake Bay. Okay. So a lot of rivers are coming, and it's a kind of a way, it's an inlet into this thing. It creates a bay, and it's a mixture of fresh water and salt water. And it turns out that lot of the seafood type of animals, they love this kind of mixture, right? So crabs and oysters and so on. So it turns out that this whole Chesapeake Bay area is a powerhouse economic engine. It is actually supporting a lot of people. They're making a living, fishing and crabbing and restaurants, supplying restaurants all over the country and so on. Okay, so it's a very important thing. But over the years, these rivers that are joining are dumping pollution, and so there has been a project to clean it up, make sure that water is good enough for these crabs to live, fish to survive, and so on. So I got involved in it because I had a large project with US EPA doing this work, helping the Bay scientists, monitor and come up with better statistics and how to comply, checking compliance and so on. So for a long, I think another thing that just like the Scout project, probably even larger than that in a way. So from 1988 onwards, for several years, I was involved in this Chesapeake Bay monitoring program, helping them with their data analysis and so on. And I produced software for them, etc., etc. I did quite a bit of work. So this is how I actually got into the environmental statistics. But you also mentioned NLP and AI. I don't know exactly what you had in mind in that.
So I was asking regarding that many of the students have never heard about environmental statistics as a subject. So
this is so there are two levels in environmental statistics, you can say. One is this kind of a monitoring, regulation oriented, etc. These tends to be small data kind of situation. Right, for example, to assess whether a particular water is drinkable or not, you just have to take a few samples and measure the pollution level, compare that to the regulatory standards. So it becomes like a simple t-test kind of a thing, right? It's very simple. So it's also called environmental statistics. So very often here, it's not the data set size, but methodologically, there could be a problem because environmental data almost always is not normally distributed. It's not nice symmetric data like engineering data. It's very skewed and it has a lot of outliers. It has, so you will have a lot of gaps in the data and so on. So it is a very different type of methodological thing. What is the correct distribution to fit and so on. But there is the other extreme, like things like, land coverage, cover change. Like, how are we cutting down the forests? At what rate forests are depleting? How it is affected of connecting to climate change. I think just yesterday, or 2 days ago, I think I saw an announcement, one of the UN or somebody is making a statement saying that when, the sea level is, we are going to see the climate change effect, something like that. They made a statement. How is he going to make a statement like that? Those also fall under the environmental statistics only. These tend to be very large data problems because the data is collected from satellites. Land cover is actually measured from satellite. You don't really send, you cannot send a surveyor to Amazon and do this. It's not possible. So you just see from the satellite because how much green is there and so on. They have a way of measuring this. And I think so many of these things are measured. So that really leads to very large scale data. So you'll have to do a lot of big data stuff. So I have students who have worked on such data sets and they get trained as data scientists because they need to learn a lot of these data science tools to be able to handle it in addition to being statistical. So environmental statistics, in fact, I think in 2020, they started a journal called Journal of Environmental Data Science. Right. So data science is a very important part of environmental applications. For example, you have to make, maps, right? It's geographical information systems. It's a very, very big field, because, you look at things as layers. So you have latitude and longitude in the bottom. That is a basic grid. On the top of that, you have land cover data. On the top of that, you have rain data. On the top of that, you have temperature, like that. So you have several layers. It is not quite like 3D. It's not like a 3-dimensional data. It's like a 2-dimensional data, but layers, right? So that is actually a special type of data structure. The kind of methods, statistical methods needed to analyze those are quite specific to that. So there are a lot of interesting stuff happening in environmental statistics. So I was again, fortunate to actually run into this problem and gives you a lot of opportunity to learn new things.
So as we were discussing, I wanted to ask you regarding the approach which you are using. So in many industries, when a statistician is preparing a data or working with data, he needs to have some domain knowledge. But as you have discussed, we have seen a cow example about fishes, and example about climate change. So all of three are totally different domains. They use totally different features. So does environmental statistics have knowledge of all these domains, or do you have any techniques to tackle this problem?
I think you're right. I think the environmental in general encompasses everything because it is the environment we live in. So our environment is food, and our environment is the atmosphere we are living in, and so on. So you're making a very good point, I think. But usually what happens is that, in a project, you're focused on a particular objective. So you learn what is related to that. I have worked in environmental data for a number of years. But I'm not a environmental scientist, right? I don't develop that kind of a deep knowledge. I think that there is a part about statistics I really sort of like because, statisticians are the ultimate consultants, right? So you go there, learn about the project, whatever you need to learn to answer the client's question, and you bring your best tool possible, apply it. And so I like that aspect of it. I don't know have you seen the movie Lone Ranger? No? This is an old movie. It's a American TV movie. So there is a problem in a village. It is set in the American West, and a Lone Ranger will come, and he'll come and solve the problem and go away. Right? So I think, I think always the show ends with saying that, who is that ranger? Who is that stranger? And the Lone Ranger. I think, so it's sort of, I think statisticians have that kind of in our role is like that. It's, we are called to help solve a problem. And that's the exciting part, right? And you come there, solve the problem, go away. But the other thing is that I really enjoy learning these kind of things. And I think that, I always have been an avid newspaper reader, whatever is there, and I like to see. So, and you end up scientists, these subject matter experts are very smart people, and they have dedicated their life to learning something so new. If they're working with some kind of a fish or something like that, they know so much about that. That is what fascinates me. They know so much about that, at that particular topic. So you spend a few meetings with them and so on. So you learn a lot about it. And I don't have to open a book, right? So I find that to be very fascinating. Of course, right now I'm working with the project with somebody from the biology department in my campus. And so they are studying birds and the bird behavior. Right, and how the birds are, female birds are responding to the male songs. Right, I think so. Maybe the other way around. I forget. I think so. Right, but that. So now all of a sudden, I have learned so much about the different way. Apparently, birds have different way of singing for different things, and the question is whether the partner bird is able to interpret it or not. That's what they're trying to learn. And these people are spending like 2 to 3 months every year in Puerto Rico collecting data, because they have to go there and spot a bird and wait and see how long when it is singing, and after when it hears, so they have recorded the bird songs and they are playing it and see how it is responding to the bird song that they have recorded. So they have controlled, they have actually recorded the bird song, 2-3 different types of thing, and they will play it and see whether that nesting bird is actually responding or not. And they have learned so much. They show me pictures. I think it's fascinating. I don't know what I'm going to do with all that knowledge, because I'm only applying Poisson regression to it. Okay, zero inflated Poisson. That's what I'm doing. So, yeah.
Moving on with the next question. You have taught courses in both applied statistics and interdisciplinary consulting. Can you speak how these two fields intersect and why it is important to have interdisciplinary skills?
See, I believe it is the calling of statistics to be an enabling science. What I mean is that, physics people, they study the physics of the nature. Chemistry people study the chemistry of nature. But statistics people, we enable the physicists to answer their questions. We enable the chemists or economists or sociologists or psychologists to answer their questions. The question belongs to them. So that's why I think it is enabling science. And I think this is really, it is our calling, I say. It is, it's not to be, feeling any bad about. So that is what applied statistics is. Applied statistics is really applying statistics. But I have to apply statistics to something. So by nature, I get into interdisciplinarity. Because the moment I have a statistical methodology, I want to actually have, or I want to apply it to a very realistic, meaningful problem. I have to go find that problem in another discipline only, right? So don't get me wrong. I'm really taken by the beautiful theory in statistics, and I have learned, in the 20s and 30s, the statistical theory, the foundations of statistics was developed. Those are all very, very beautiful. And I think one must learn it, But, however, at the end of the day, I think that, when you see that there is a problem, it's a real problem that's going to affect a lot of people, like environment or health issue, things like that. And so you take that problem and there is a question related to that, how do we improve this? How do we improve the delivery of healthcare? How do we improve? Like that's something that's has a social significance. You take a question like that, formulate that into a quantitative question or hypothesis, and collect the data or download the data necessary, apply statistics, answer it. That is the full spectrum, and that is really satisfying. So it seems to me that there is interdisciplinary by nature. So if you are an applied statistician, if you do not have that interdisciplinary aptitude, I don't know that is the right word or not, but then you are lost, really. Then you have a tool. What are you going to apply it to, right? Of course, we need people to develop tools, right? So you need somebody to come up with better methodology. So there are a lot of people who are doing that, and that's good. And that kind of a theory is very necessary, right? So I think that there is a very interesting way to think about this. So you have a knife, right? You have a knife. And what is the best thing you can do with the knife? Cut vegetables and cook, right? The knife. But what happens when you're doing that? When it becomes dull, the knife needs to be sharpened, right? So that is not applied, right? That is the theory. Sharpening the knife, right? Sharpening the knife. That is the theory. So, you need both. But I think that applied, it does not become applied unless it is actually interdisciplinary, because you immediately apply it to some other discipline. Usually, you cannot do a t-test on t-test. You have to do a t-test on a variable. That variable is coming from some application only. So you cannot take the interdisciplinarity out of applied statistics as far as I'm concerned. They are simultaneous. So you can see all the talks. Every talk has data. No matter how theoretical that talk becomes very soon, always starts with a motivational problem.
So have you worked with any example in which theoretical statistics is derived from the application? Like the results which application is giving is pointing towards some kind of theoretical result which was unknown prior.
I mean, there's so many. I think that I'm trying to kind of see, early developments. Many of them are actually, the statistics was created to answer certain questions, starting from correlation and all these things, right? T-test is derived. I think all these things are actually motivated by real life applications, without any doubt. I think that things like principal components and all these things were driven by the necessity of reducing the dimensionality of a problem. In psychology, they collected lots of data. a questionnaire will have 100 questions. So each person is giving 100 pieces of information. You cannot summarize. So you need to have a way of summarizing. That is the kind of need that developed, that motivated the development of principal components analysis. So things like that. I feel that, of course, the theory in matrix algebra was there. The statisticians necessarily did not derive it. They made the connection to it right away. So I think that too many examples to even to state one. It's one of those cases. I think that, if I think of something very catchy later on, I'll mention it. But I think immediately I feel that all the very well-known ones are actually derived by, Dr. Sierra, I think this morning, I think Ashish was actually talking about example of the skull measurements. Right? And that is actually motivated the development of discriminant analysis. This Professor Rao's book talks about it. So I think many of them, too many, Malnovis distance. He created the Malnovis distance actually for measuring, distance in two high-dimensional, things. And he said, hey, it needs to be weighted by the variance. So, that was because of the a practical application where he saw that things are highly variable, different components have different variabilities, etc. So how do you do that? So I think quite a few examples that are, compelling examples.
And even the beginning of statistics was from problems like gambler ruin, which were solved by mathematicians to actually calculate the probability of ruining. So.
A lot of the probability work early on was motivated by gambling, I was told.
So, moving away from your academic life, I just wanted to ask you some questions regarding your administrative life. So, as a chairperson and program director, what challenges have you faced, and how did you navigate these challenges? So, from an academic background, transforming it into a chairperson, you have to manage a lot of people. Your focus is not advising or directing students; it is to direct a program. So, what kind of challenges did you face?
See, a program director, main job of the program director is to, facilitate, creation of new programs, maintaining the curriculum, of a current program, like make sure that it is up to date, etc., and recruiting students and so on. Okay, so that is the kind of thing the program director does. It has a lot of administrative, following up paperwork and so on. But many of these things you cannot do all by yourself, right? You always need to rely on your colleagues. And interestingly, program director is a typical faculty, not necessarily the chair of the department, head of the department. So you don't really control other people. I mean, you don't have any authority on them. Right? How do you get work from somebody to whom you cannot really say, do this, right? That's a special skill, right? So you have to somehow, motivate others to actually do what you want them to do without actually giving them orders, right? So program director is like a little bit, so you have to get people excited and find what is something that others can do. And if I see that one of my colleagues is very interested in a particular topic, I can say, hey, can you develop a course in this one that might be very marketable like that? Also keep an eye open doing like that. So it's a very much like colleague to colleague. So you have to maintain that thing. If you start pulling, rank on the other people saying, I'm more senior than you, do this, very soon people will not do this. Because I am a believer that at the end of the day, you can get from others only what they're willing to give you. Okay, this is a very important thing. Right? You cannot get, if somebody, doesn't matter how much I force them, if they are not willing to give it, it is not going to come to you. So you have to, you have to be you have to deserve it. Then you get it. Okay, so that's how it is. But being a chair is another challenge. Chair does have authority. Chair of the department can say, I want you to do this because this is needed to be done. Look, this is the objective. This is the delivery. This has to be delivered by the department. Someone has to do it, and you seem to be the best. Like you have the authority to approach people like that. But still, people have to do it. And the other challenge with chair is that chair is an administrator, right? It's a little bit but at the same time, you see your faculty colleagues every day. So you're, in the meetings and have lunch with them, etc., every day. You're also teaching some courses. So you're their colleagues. So you're managing your colleagues. At the same time, upstairs, dean and all these people are thinking that you are part of them. Right? So chair has this unique position. Administrators are thinking that the chair is an administrator. Faculty are thinking that he's like a class monitor. He's like he's like us only, or she, right? So so chair is a little bit tricky like that. So but these are all interesting positions. I think that those of you who have the kind of the leadership aspiration, you should aspire to become a program director or chair, because at the end of the day, that you explore the different aspects of your personality. Because career is just an excuse for your personal growth. I think of profession as not necessarily different from my rest of my life. It is also personal growth. I want to expand this thing. I want to explore this aspect of my ability. So I look for that opportunity in the profession or outside, and that is why you see my my activities are defined by that.
So, do you think we also research about you regarding Chinmaya Mission? So, do you think Chinmaya Mission helped you to navigate through this challenge somewhat in spiritual way?
That's a what Chinmaya Mission does is that it facilitates study of Vedanta, right? So study of Vedanta, and it turns out that studying Vedanta is actually it's about knowledge. How does one come to know? What does it mean to say I know something, and so on? All these things are very important for a Vedantic study. So the lectures that I've been listening on this thing has been very useful. I think it has made me more introspective than I have been, and so on. So it definitely, I think, no doubt about it. I think that it has impacted me. I think that give you some examples. I'm thinking. It actually, that, how do I put it? So Vedanta is actually it's a study of oneself. It's actually about study of oneself. Okay, what am I? Who am I? What is this world? What is my relationship with this world? This is kind of questions that Vedanta talk about. Right? Vedanta hardly talks about anything about God, or is not very specific about those things. It's a very abstract discussion about this. How should I How should I interact with this? I have to, on a daily basis, I have to deal with a lot of people, a lot of this thing, and so what should be my attitude in doing that? With what attitude I should do it, and so on. So it is a complete Vedanta is one. Some critical side benefit of it, is that you become very aware of your surroundings. You become very aware of your own behavior relative to other people's behavior. You become much more conscious of the fact that I'm getting upset. Right? One time you don't know whether you're getting upset or not. Everybody's saying, hey, you're upset. You say, I'm not upset. But at some point, you say, I am getting upset. So like that, I think it has that ability to do that. So it has had a tremendous impact. I think, no doubt about it. I think.
Coming back to the technological innovations going on around us, We have seen increasing use of artificial intelligence and machine learning in various fields, including education and data science. We've also seen the rise of powerful language models like GPT-4. Do you have any concerns about the potential impact of AI on the job market and the societal issues as well? And how do you think we can best address these challenges as we continue to develop the technologies further?
You know, it so happened, a coincidence, right? Yesterday, there was an article in Washington Post, right? Yesterday, that addresses this very question. It so happens, right? I think I didn't get it by searching because I always browse the Washington Post headlines and I saw this. And it is, I can share it with you. It's a very interesting. They ask this question: how AI going to impact jobs? How this thing? And so interestingly, what is the last big disruption like this? These are called disruptors, right? You know the word disruptor. So, we go back, I think the one probably everybody can relate to is industrial evolution, right? Isn't it? And so machines coming instead of bullock cart, car. Instead of the this thing hand moved looms, they have looms that are powered by steam engines and so on. This is that's one later on engines, steam engines and so on. So it had impact on life. I mean, it has impacted a lot of people. So I think that something like that, a disruptor like that, it will not impact life and jobs, etc., is a very unrealistic expectation. But there is one thing I have noticed is the following. The kind of things that our AI is being employed to right now is a job that humans either they're incapable of doing or they are not inclined to do. For example, if you had to say that I want you to multiply these 1,000 numbers from another set of 1,000 numbers, and I want you to bring me back 1,000,000 products. Suppose I ask you, unless you're totally desperate for money, you are unlikely to do it. Isn't it? Isn't it? I give you 1,000 8-digit numbers, and I want you to multiply and give me the answer. Right? And you will say, no, you yourself will say that, no, I think I'm going to write a R code for this to do this, a Python code to do this, right? Isn't it? You will unlikely to do it. So, but the kind of work AI is doing like that, actually. A lot of it is kind of assembling data and collecting, putting things together, looking at all possibilities and finding the most optimal, like that. That's the kind of things doing. So I think that, no humans are really doing that kind of work. So AI is not replacing anybody. But on the other hand, AI is helping us do better job. Like, there in the article is talking about how AI is going to help doctors make better decision in terms of who to operate, who not to operate on, right? Things like that. So it's helping. I think yesterday's talk by Ms. Ishani Sarkar talking about how AI is helping to figure out fraud or how to help a customer better, etc., etc. And the kind of work that is going on, he said, humans are not you cannot really do this. You have to browse through millions of records in one database, millions of records in another database. That's humanly not possible. So it is not replacing anybody's job. Because right now, if the AI is not there, that job is not done. It will wait for the tool to come up with. So I think that this is going to be, impact is going to be slightly different. I think in most cases, it's going to help people do their current job better. But there will always be a person needed to do that. Right? So in fact, I noticed that, but we will all need to retrain. I think that today, if you graduate and if you go to an interview and if you don't know, they'll ask you a number of these software, that's AI AI type of tools, and they will mention the names. And if you are unable to, answer their questions, they will say, no, he's not up or she's not up with this current development. So you'll have to be able to use the tool. But don't forget that the population is increasing. There will be newer problems to do, but there is always, like teaching, so there is a human element there, and I don't see it being completely eliminated, right? So I think that will chat GPT, as somebody was saying, that maybe you think the teachers will become redundant. I don't know. I think current chat GPT is just a toy, and really it's not. But of course, they're saying they're coming with the new one. I have not seen the new one yet. But right now, I think I think I just wanted to. I thought I saw your question. I said maybe I'll come up with a funny example for you. But last night I couldn't get in because it was so busy. For the free version, it is not even accepting any more questions. It is so busy. So I guess that I'm not sure. We should worry. I would say, as a younger generation, you should definitely be concerned. But you should not despair. I think there is, you should say, now you are playing with a different set of tools. And you say, how are you going to do my best life out of this, my current scenario? That is the way I would approach it.
So, do you think in the concept, like there is a movie called Terminator, basically in which that artificial intelligence overtakes human capabilities and starts to think on its own? So, do you think there will be a time, not as in AI will start killing us, but there will be a time where AI doesn't need humans and it starts thinking on its own based on the algorithms, and then it will be more useful?
That is an interesting question. I think, where I am not the expert to answer these questions. Okay, I think so. My responses to this will be very pedantic. I would say just a lowest level. You should say, think of it as coming from a lay person, right? Not an expert. What is that differentiates, lack of better word, real intelligence versus artificial intelligence? Humans have this additional element, right? Because if you, same human, identical conditions, you are exposed to the identical stimulus, you will behave differently depending on your mood, right? That's not the case. What machines are not defined like that. By definition, machines are the ones who will give the same answer for the same stimulus. They're not, if it gives you different answers, it's not called a machine. By definition, a machine has to give the same answer. Whereas, by definition, a human, what answer the human is going to give is not completely determined by the stimulus only. It's also depending on what is going on in your mind. Right? That is what Vedanta calls it, your qualities, gunas. That is what Vedanta actually addresses this very well, actually. It is your gunas. So that is that is why food is running out. Say, some of your guests are very upset. Others are saying, okay. Right? If we are all machines, we will all be upset, or we will all be not happy, and okay with this. So this is actually what I think is going to make. So that is why I am not so sure. I have not seen anything that will actually kind of keep that kind of element in this thing so far. You can make it random. I can put a coin tosser in the machine and make it this thing. That is not the same as I don't coin toss. I have a mood. That mood is not really random.
It has some logic.
It has its own logic, but I don't know what it is. Right? That's why we all see in movies, you say, I cannot understand you anymore, right? That's what so that is what we mean. Same person, but we cannot understand anymore.
So do you think AI will create some new opportunities? Like while we were thinking about computer revolution, many of the people's doing data entry jobs are now obsolete. So with the help of machine learning, we are directly extracting the data, processing it and providing the valuable information. So do you think AI will scrap off the jobs which are not that much useful to society, and people will move towards some kind of new or jobs which require more thoughts or thinking?
I think your question has plenty of answers itself. I think all those things that what you say is true. I think that so many different ways. I think people have to. I think some jobs will be eliminated. I am almost certainly certain. And so if people don't react to it, they will be out of job. I think so. You need to find how to retrain yourself and so on. And I think that many times improving what we call improvement or development, it's not entirely clear that is really improvement or development. So I think that if those of you who become leaders should take responsible actions. I think that when, this is what people say about, garbage, creating refuse. When you manufacture a product, you should say what happens at the end of its life cycle. This is a very important thing. Not everything is manufactured that way. That is why we see so much garbage in the world. So when they sent out satellite to the world, this thing, they didn't figure out what to do when that satellite is out of battery. Right? When it becomes junk, they didn't think about that problem. They said, "Oh, there'll be only few running around." Very soon there are not few. There are millions of objects in the thing floating around. So we didn't think about that. So I think at least this time when AI solutions are launched, I hope the leadership really says, okay, what are we going to do with the people who are displaced? I mean, they should find a substitute for this and slow down the growth a little bit. Don't get into that profit mode that quickly, right? Make sure that the people who are displaced are repatriated properly. And we are talking about a generation. Right? I'm at 55. Don't make me learn something new at 55. Like that. I think that we should be very sensitive to those needs. I think otherwise we are not a society.
Also, besides your academia, you are also involved in Yaksha Gana and community plays. So, can you comment on how these interests have influenced your personal and professional life? Also, can you elaborate upon how your work on Chinmaya Mission has helped you spiritually?
See, I think it is more accurate to say I was involved in Yaksha Gana actually, because I have not done it for a while. But I grew up in Kasaragod. I'm originally from a small village called Neerchal in the Kasaragod district, which is the northernmost district of Kerala, bordering Karnataka. And this is the area where Yaksha Gana is very, very popular. That's where it is born, and this is very popular even today. If you go during the season, go to Mangalore, that whole area, minimum of 45 to 50 professional troops are performing every day. That is how popular it is. People are watching Yaksha Gana every day during the season. And so it's very alive. And it's something, a wonderful thing. It's a complete art. It has music, dance, and makeup, and talking, impromptu. And it talks about the literature. It talks about this, spiritual stuff. It talks about Ramayana, Mahabharata. The stories are from there. It's a complete package of art form, if you ask me. So I was completely sold by this. So what happened is there is a few people there in our area who got together, and we had one person who was very, very good, and she taught us all how to do, and we put up a show. And we did several shows actually. We got called to do this to many places and so on. And but I was in general being interested in plays. I don't mind, anybody calls and say, you want to do this role, I'll do this role no matter what it is, because I completely enjoy the production environment. How we are doing this broadcast, so many people are involved, so many little things, everybody has a little job, so you perform that, and you may have a very small role, but you're part of this big project, and I enjoy that environment. And that is what a play production is like that. Is you have a small job. Maybe all you're doing is to banging the cymbals like in in the Man Who Knew Too Much, movie. That's all you're doing. That's your thing. But you have to read at the right time, and you're waiting for it. Enjoyed it. So Yaksha Gana is really a spiritual experience for anyone who is doing that. And so that, it helped me enunciate, to speak in a certain way, all those things. And I think that helped me practice my communication skills, speaking to people, and, getting in touch with your audience. All those things I learned while doing this. And of course, dancing, I never took a step in my life. So it helped me get out of my comfort zone of doing things. And the other thing that it actually connects with my interest in the Chinmaya Mission or Vedanta, because, it is one way to understand this is that the connection between the universal consciousness and us is to think of us as it's like we are playing a role, right? And it is a role that we are playing. It's not real. That's what Vedanta says. And so this is Yaksha Gana, or being in a play, is an actual demonstration of that. Because I am playing the role of Rakshasa, or a demon, right? But I am me. So I have to be simultaneously on the stage. I should be very aware of where is I cannot step there. That is too soft. I have to be very aware. But at the same time, I'm actually in another world of that make-believe world of talking like I'm Narakasura, right? And that kind of a thing, I think that is really, in a lot of ways, that is what is happening for us, because there is inside of us is that calmness that all of us have, right? So it is actually, so this actually helped me a lot in terms of thinking about this. So everyone has that same calmness, right? And it is the outside that we are doing. So once we understand that the outside is just a reaction to the things that we are being exposed, we can always go back to that inside and help. I think many of these exercise, Yaksha Gana and Chinmaya Mission, everything kind of comes together to me within the study. So.
Moving on to next question. The Neelkamal School of Mathematics, Applied Statistics and Analytics offers two master's programs, namely M.Sc Statistics and Data Science and M.Sc Applied Statistics and Analytics. Three other programs offered are streams of Applied Statistics and Analytics, Data Science, and Artificial Intelligence. Did you have any chance to look into the program structure and reflect on their suitability in terms of international benchmarking, imparting graduate abilities, industry preparedness, and placement?
Yeah, I should be very honest with you. I have not had a chance to study your curriculum. That's a long project, right? It's not going to happen in a couple of days, right? So it's a long project. But, you are a very new department, new university even, right? 15 years ago. And so in such a short term, right, I see that, you have created a lot of programs. And, at the end of the day, there is an American saying that says proof is in the pudding. You know what that means? What does that mean? Proof is in the pudding. That means if you have a question whether I say, Dr. Neerchal, do you know how to cook pudding? I say, I give you a pudding. I made it. Proof is in the pudding. You eat it and see whether it is good or not. If it's good, I know how to cook. If it's not good, I don't know how to cook. So what I'm seeing is all the product here, pudding. I see you guys. This is the product of the system. And I see wonderful students. That is why the other day I said students have the first chance to ask questions. Of course, you ask so many good questions. So I think that, there may be improvements to be made, etc. I'm sure you're constantly trying to get better. But you already have a good product, I think, because proof is in the pudding.
So adding more to that question, have you ever interacted with any of our professors, and do you know about their research publications or their interest in research?
See, the person I know fairly well is Dr. Madhava. And I met him in Botswana a few years ago, and he hosted a conference there. He was a main organizer there also. He's a terrific organizer. And but in terms of research, I'm only beginning to learn. I think I met a few of your younger faculty this time, found out what they're working on and so on. Some of them are still doing their PhD and so on. So I definitely am looking forward to an opportunity to interact with them in whatever way that is possible, and we'll be very happy to interact with all students also, PG or UG students. And I think is one thing, people who, especially those who become like a academician like me, we are there because we just enjoy that environment. And remember that there is no university unless there are students, by definition, right? So, in fact, university is not a building, not you, not me, not by yourself. It is when you all come together, it becomes a university. Classic example of 2 + 2 greater than 4.
Thank you so much for your valuable time and patience, sir. With this, we come to end of this podcast session. Thank you for tuning in.
Thank you very much.